Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have minimum number of operations to make the elements in array distinct. So first we will go to the problem statement. Then we will discuss the logic building parts, and then we will jump on the code iterations. Yeah. So you are given an integer array nums, and you need to ensure that the element in the array are distinct. How we can ensure to achieve this, you can perform the following operations any number of times. We can perform the following operations any number of times. What is the operations? Remove 3 elements from the beginning of the array, and if the array has fewer than 3 elements, remove all the remaining elements. Remove all the remaining elements. Now note an empty array is considered to have a distinct elements. Return the minimum number of operations need to make the elements in the array distinct. So the question is very straightforward, and it's marked as easy tag also. So if you can, so why it's easy tags? Because if you can look on the constant, it's on 1000. So if you can run the standard brute also, then big of n square kind of complexity, then also you are going to get an AC for sure. But we will not discuss the brute force ones. I think everyone should be able to write the brute force. We will directly discuss the optimal solution, most optimal solutions of this particular process. And yeah, before start, like I have to give the kudos to my wife, because the most optimal solutions is basically just came to our brain also. So on the very first go, she is able to write the very optimal solutions on the first go. So big kudos to her. Yeah. So I think on the problem statements, it's very clear. So what we have to do for every operations we are performing, so we can remove the first 3 elements. We can remove the first 3 elements from the given array every time. And let's suppose if your array is after doing the operations, your array are going to shrink. Your array are going to shrink by 3 like this. And at a particular times, so let's suppose it is not a modular divisions of 3. If the array size is not a modular divisions of 3, then at certain times you have some elements remaining which are less than 3. So on that case, remove all the remaining elements. So if the array has fewer than 3 elements, remove all the remaining elements, and after that you have an empty array. So that's the note they have given. Note an empty array is considered as also a distinct elements. Now what we have to return the minimum number of operations to make the elements in the array are distinct. So we can run the operations as many times as we want, but after that, finally what they are looking for to make the array having all the distinct elements after doing the above operations, after performing the above operations. Right? So I will not discuss the brute and other better solutions. I think you guys can write it on your own. But on optimal solutions, what actually we are looking for, I will just quickly give you the basically the test of the intuitions, how you can think of this. So now let's suppose, okay, it started crying again. So now I think it's working. Yes, it started working again. It's crying and working. Sorry. So let's suppose we have an array elements A again, then B again, then let's suppose E, F, and then G. So let's suppose that is the nums is given to us. Now you can see, like our array has repeated elements, but we can delete 3 elements. We can delete a group of 3 elements. Group of 3 elements from very first three every time, and we can shrink our array, and like this way, when our array has all the elements are unique, we are done with this. So but to make the array by shrinking it by 3, by shrinking it to 3, like this way, what the number of operations we have performed of shrinking operations we have performed, we can return that number. So you can say what actually the intuitions. We can first remove these first 3 elements. So first do a dry run of the brute algorithm. So we can remove the first 3 elements, and if there is some way, we can say, if after removing the first 3 is the resultant array. What is the resultant array? From here to very last. So from here to very last is our resultant array. So after removing the first 3 is our resultant array. All has unique elements. All has unique elements. So is it so? Yes, A is unique now, B is unique now, E is unique now, F is unique now, G is unique. So on that case, our answer should be 1, because just performing only one operations, this A, which is going to be repeated due to these occurrences, this B is going to be repeated because of this operation, this occurrence, after removing the very first occurrences, we are able to make the resultant array starting from here to very last is going to be unique. So what actually the intuitions? So rather than starting from front, because front to here we are omitting every operations. So I am interested what the resultant array, and because you can see, right, we are interested in the resultant array. Let's suppose they have asked for the resultant array. What is the resultant array you can form after performing the operations? So at very worst case, your resultant array is going to be empty, is going to be an empty, because you are landed to removing every of them. If this A's occurrence is at very last, and let's suppose everyone before that if you have an A, like this way. So then on that case you have to remove till this point for sure. Then maybe you are going to left with one elements, and if it is not divisible by 3, then if it is divisible by 3, then you are going to make your array empty. You are going to make an array empty. So that is why, like, very mathematical inductions it is coming. But I think you guys agree to me. At worst case, we are going to remove all the elements. All the elements. So our resultant array is going to be empty. But maybe some better case. We have some elements. Let's suppose A, B, C. We have it. Then for this case E, G, we have these elements, right? We have these elements. And let's suppose there are some best case where all the elements given to you X, Y, Z, A, B, C, all are initially they have given to unique. Initially array has given to us an unique. So in that case, our resultant array is the given array. Is the given array. And maybe some better case that we just see after performing one operations we hit it. And on worst case we need to remove all of them. So on every case, what is the resultant array? So our resultant array could be some very some portions of the array from the very last. So okay till this point, Shouvik, I am completely agree to it. But what portions? So it is also very simple, guys. So let's suppose you have elements A from very back, B, then C, then let's suppose A again, then let's suppose you have E. So what portions from very last? What is the resultant array? I have to say from very last is unique altogether. So can I say this portion is fine, boy. This portion is fine because A is single occurrence till this, B is single occurrence till this, C is single occurrence till this. But after encountering this A, this A is going to be repeated. With some A. The resultant array we are following from this point. It has repeated to some portions of the resultant array. So from this to its right. So from this to its right, which I am highlighting repeatedly, is a valid portions. But before that, there is a fast repetition start. So from this point of this array, the first repetitions has started. And as the question has asked, to remove all repetitions. It should be unique. So we have to omit all the repetitions. So that's the reasons. I am very greedily say, I can very greedily say, where the first repetitions altogether started, which is nothing but this. I can say from this I have to remove all of the left. I have to remove all of the left for sure. And now when we know what is from these particular points, I have to remove all of the left. I think we are ready to our answer. And now what we are interested then? What is the left portion length? So if I can giving you this index, that this is of index I, this is the index I. So can you tell me then what is the number of operations to its right? What is the elements present to its right? It is nothing. So let's suppose our elements has total of n elements. And when let's suppose we are iterating from very left, as we are doing on the dry run, doing on our dry run, and on very left iterations, let's suppose at we are able to successfully count number of elements from right with no repetitions, with no repetitions, with no repetitions. So that is basically your count basically store 3. Count basically store 3 because you are able to iterate from your right to count number of elements where there is no repetition, where there is no repetitions. So what is the portion? So from count elements from the right is okay, from count elements to right is okay. So what are the non okay? So non okay or specifically I have to say have to remove is nothing but if you have total n elements and you know count elements are okay, what are non okay? N minus counts, very simple. And if you know this number of elements you have to remove from very first and you know on one operations you can remove 3. So then to remove n minus count elements, how many operations you need? N minus count whatever it is divided by 3, and if it is coming as a fraction, maybe it can come as 3.2. so on that case we will take a seal of it. We will do 4 operations because 3.2 we are not going to encounter. We have to perform a complete operation. So we will do a seal. We will do a seal here. So 3.2 is going to be 4 operations altogether. So this many operations we at least have to perform. So yes, guys, this question is as simple as that. You have to just iterate from the right and you have to set your point. You have to set your point where the very first repetitions has started. And before that from iterations from the right you have increment your counter variable. So that many elements are okay. What are the non okay? N minus count, and how many operations they needed? N minus count by 3. Seal of that the operations is needed. So exactly that things I have written as a code. You can see I have taken n as a length and default it because we need to check where the first elements repetitions has started, and I have created a counter variable. So count basically from right how many are okay. So I'm iterating from n minus 1 to 0. So that is a reverse operations how we are doing in Python. I am doing that, and if a particular elements dd of like on our default dict holding some value of nums of j, so that means there is a repetition. This element is already present in our default dict. So what is the remaining? So this is nothing but the non okay. So count is the okay element. So remaining is the non okay from the very starting. What is the remaining elements? So remaining is nothing but the non okay elements, that is of n minus count. And when we encounter that, we are returning from the math.seal of remaining by 3, or more specifically n minus count by 3. Exactly same things I have done. And else what is the case? That is the very first operations. I am increasing its counter of this number as all. I am just creating an entry to my default dict that this elements has just occurred, and I am increasing my counter also. Because this I have encountered one more okay elements from the right to left iterations. So exactly these things that we have just written, we have done the same things. The pseudocode or the intuitions we just built, we just converted to a code versions of it, and it is as simple as that. And let's suppose all the elements are unique. So on that case, this if block is never going to be executed. So for this test cases, you can see like 6, 7, 8, 9, where all are unique. So they are all we are going to push everyone's to our default dictionary, and for none of them there is a repetition. So if that is the case, after that please make sure you are returning a 0. So that means your array has all the elements are unique. So you don't have to perform any operation. So yes, guys, this question is as simple as that. And quickly now we can discuss the time complexity of this. So the time complexity of this particular solutions is nothing but of big O of n. We are not doing any extra things to this. We are just iterating from right to left, and we are performing our job to this execution only. And on space parts, we are carrying a dictionary to checking the reoccurrences of a particular element, so which is going to be a take of big of it. So that's all about the most optimal solutions of this particular questions. I am pretty sure that going to be the most optimal solutions, because my submissions is like 100% faster, and it is almost taking off 0 milliseconds, because the constant is only 100 and we are able to solve it on big O of n only. So yes, guys, so that is for sure of most optimal time complexity and most optimal space solutions for this particular question. And I know, and if you guys are able to understand till this point, please do subscribe to our channel, and please share the videos who are basically prepared for top product based companies, and also brush up their DSS skills, and please turn on the notifications so that when we are going to be live to our next video, you will get the notifications as soon as possible. So that's it, guys. That's it for today. Let's meet tomorrow with another beautiful question. Bye, guys. Bye.